I'm going to steal our formulas from this page and paste them so we have them available over here as well. So this one, the instructions don't say simplify, but the instructions say write each expression as a single logarithm. So again, we've got the green arrow. We're moving from the right-hand side to the left-hand side. What's different in this question is that sometimes there might be more than one log law that you have to do. So eventually, I think you'll be able to do it in one step again. But in part A, okay, we have a log plus a log, which makes us think of the first one. We also have a 3 out in front of the log, which makes us think of the third one. Now, in the first one, okay, if we look at our formula sheet and we look at it carefully, the first formula says we can only do the first one if you have one log plus one log. In other words, there's no number in front of either of those logs when they're added. The bases have to be the same. In this case, we have the common log. Everything's in base 10 until we get to part C. The bases are the same, but we have that 3 out in front. So as a step 1, we're going to use the third log law and move that 3 in as an exponent. What does that allow us to have now? Now we have log plus log. And the rule for when you have a log plus a log is that you can multiply. And now we have a single logarithm because all of this, I can put brackets around it, all of that is inside of one logarithm. So we've succeeded in writing it as a single logarithm. In part B, we've got adding, subtracting, and numbers in front. Okay? So one of the things you might start to notice is that when you have multiple log laws, the first two that are listed only work when you have log plus log or log minus log. So you almost always have to do the last one first. In order to use the other log laws, you can't have numbers in front. So anytime you have numbers in front, like we do here, very first step is put those numbers inside as exponents. Now, we've got a log plus a log minus a log. So we could do this slowly. For the first one, I'll do it slowly, and then I'm going to show you a way to do it much faster. Okay? First of all, a log plus a log is our first law, so I could put the first two together by multiplying. And I would still have the last one by itself. And now I have a log minus a log. So that is dividing. I have xy squared in my numerator and z to the 4 in my denominator. Once again, we have succeeded in writing it as a single log. Now, I'm going to want you to be able to go from this step to this step all at once, even if it's longer. So I'm going to add an example here. I'm going to call it, how about in between B and C would be B.5? Okay, okay with that? So example B.5. We want to write this as a single logarithm. I'm going to give you log A plus log B minus log C minus log D squared plus log E minus log F to the 5. Wow, there's a lot of them there. Okay? They're all single logarithms. Notice there's no numbers in front. I already put the exponents in. So, for example, the D squared and the log after the 5. There could have been a 5 in front and a 2 in front, but I already put them, so each of them is a single log, and we're just adding and subtracting as we go. And instead of doing 2 at a time using your log laws, see if you can figure out what I did. Log done. So how can we use those log laws, and what's the shortcut that I just did to do that all at once? How did I figure out where the A, B, C, D, E, F went? Any ideas? Anything that was negative, whenever you're subtracting, that always ends up in your denominator. Anything that's positive, the A, the B, and the E, those all end up in your numerator. Nice. Perfect. Then part C. is log 2 of 6 minus 3. It's a single logarithm, but it has a minus 3. We want to write this as only one logarithm. In order to do that, well, the only way we could combine this if it was a log minus a log. The question is, could you write 3 as log base 2 of something? What would that have to be? And this question is really asking you if you really understand what a logarithm is. A logarithm solves for an exponent. Okay? So if the answer is 3, that's telling you the exponent would have been 3. And if I want to write it as log base 2, the base would have to be 2, the exponent would have to be 3. What would the question mark be? 8. So now I'm going to erase that question mark. And notice that log 2 of 8 is equal to 3. Why did I want to do that? Because now in this second line, I have a log law. I have a log with the same base, one log minus the other. What's our log law for subtracting? We divide. And you could leave it as 6 over 8, or you could reduce it to 3 over 4. Either way would be fine. So again, combining as a single logarithm, that strategy is taking the right-hand side and simplifying it and writing it as the left-hand side. Okay, questions for this one? 5, 8, 11, and 18.